large panel system structures. So what are LPS structures? Well, a bit of a backstory. In the 1950s, many local authorities across the UK struggled to meet demand for social housing. This was a difficult time post-World War II. And as an industry, we needed to think of a quicker way of constructing our social housing. This quicker method was fabricating standard panel systems off of site, delivering them to site, and then assembling them into multi-story structures. This was a quick process, and the panel quality could be closely monitored during in the off-site workshops. The leading manufacturers of these systems were Bison, Larsen Nielsen, Taylor Woodrow Anglian, Jesperson and Waits, and there's a few others as well, they make those popular ones. And here we can see the concept illustrated for us. So essentially, large panels are put together with in situ stitching. The system is a gravity-based stability system, and it relied on the panels being tied together using the hoops as shown there in the middle. The overlapping hoops that project from the panels are then linked together with a dowel bar, and then they're cast in. As you can imagine, if these hoops were missed, or the dowel bar missed those hoops, then the structure will be weakened considerably. And what is worse is that this missing loophole, or the dowel that's missed the loop, is totally masked by concrete. So you can't tell whether it's hit or it's missed at all unless you physically break it out. And then the photo on the right there is a photo I've taken that's a typical LPS structure kind of type, high-rise social housing. So what are the associated risks? Well, the risks on these buildings are similar to other structures, really. However, the risk is magnified due to the construction type. So such risks as fire, gas explosions, accidental impact loading, or overloading the structure, all these risks, they can happen on any structure. However, with LPS structures, these are particularly sensitive. And this is due to, and this is the big one really, the disproportionate collapse mechanism, or pancake collapse. An example of this is shown on the left at Ronan Point. A localized failure in one floor or panels, that then courses through the structure and causes that disproportionate collapse. The Ronan Point collapse was in 1968, and it was reported to be a gas explosion that happened on one floor that caused the panels to fail in one apartment, which then resulted in the collapse of several stories of the structure as shown. And this disaster resulted in 4 deaths. It's commonly recognized that Ronan Point, this incident resulted in the introduction of the disproportionate collapse or damage as a structural concept, and also led to widely debated changes in the UK building regs. And it's absolutely key to consider this mechanism during demolition works of these structures. It's also worth noting the legacy of this Ronan Point collapse because it's quite profound. It included the building type being put into its own risk category, obligations on the owners of the buildings to investigate whether these how well they were built, essentially, and to strengthen the structures, as well as an amendment to the design codes and building regs, as I've previously mentioned. This is a serious issue, and it requires some serious consideration. We cannot afford to for a failure like this to happen on demolition sites unless you've got a very large exclusion zone in place, essentially. And if you take one thing away from this talk, it should be the 2 thoughts or risks that should cross your mind when an LPS structure is mentioned, and that is the latent defects and the disproportionate collapse mechanism. Latent defects, that is a fault in the structure that could not have been reasonably spotted during a thorough inspection. So example, the dowels through the hoops. These can become a problem during progressive demolition, and you shouldn't assume something is there when it may not be. And the disproportionate collapse is the disaster that you can see there. So it's a relatively small failure leading to a very large collapse. So what do we do with all this risk? What do we do with all this risk, and how do we go about the demolition? Well, there are several methods that are commonly employed to mitigate risks, and that is exactly what we're going to cover today. On the whole, it is to have 2 things. a very in-depth understanding of the structure, which is garnered from a desktop study plus intrusive site investigation. And the other one is temporary works designed to eliminate the risk from both overloading the structure and structural instability. So with regards to LPS structures, we have at Tandon extensive experience in preparing demolition reports, advising on demolition methodology, and preparing demolition temporary work schemes in connection with the high-rise structure LPS structures. Previous projects have included demolition and construction strategies, which include demolition using cranes, so deconstruction with cranes, removing the structure top down with either a crawler crane or a tower crane, panel by panel. Another method is ultra high reach demolition. This is demolition using an excavator with a very large arm, removing the structure from ground level outside, and the photo is shown here. And then the other one is top down demolition in situ. That's using small plant on the structure, removing the structure mechanically floor by floor. And on many occasions, a combination of these techniques are used. So the first one I'm going to look at is, sorry, that's my phone deciding it wants to talk to me. Excuse me. So the first one, let's look at the deconstruction with cranes. So usually a tower crane or a crawler crane, and it's a very controlled method of demolition and mimics the construction method that was typically used to build these structures. Each panel is supported and then removed using the crane and lifted to the ground for further processing. Small excavators are often required to persuade panels to break free from the structure. And I say persuade in kind of quotation marks. So just to break out those in situ strips to release those panels. And then the propping of the panels, which is shown in that pink on the bottom right-hand corner, that's to provide stability to the panel just prior to lifting. A key risk to the project is the crane itself. When cranes collapse, it always makes the headlines, and that's for good reason. They can cause a significant amount of damage. There's also a risk that a crane is winded off, which can have large time and cost implications on the project. There could be a lot of standing downtime while it's quite windy and the crane can't be used. So in that case, the combination of using the top down, using small plant is often used as well as a combination. The other one is the high reach demolition. So this is using a high reach excavator, and this is a great way to remove people from the structure entirely during demolition. This is because the ultra long reach excavators are used to carry out the works operating at ground level outside of the structure extents. There does remain, however, the risk of fly, and fly or ejector is small bits of concrete debris that are projected out from the structure during the demolition. And this can happen when the crushing jaws of the excavator attachment are cracking the concrete, and then bits of concrete can split off, being fired out at different directions. It's difficult to predict where they're going to go when the cracker attachment is biting onto the concrete. Little bits can ping off. The best solution here is to have a large enough exclusion zone, so the trajectory of the fly falls within the exclusion zone. But this isn't always viable, so screens can be used to mitigate this risk. An example of one is shown here, which was used on this job, but larger ones can also be used. Another screening method that can be used is when they use a demolition curtain, which is like a big screen, and it's hung from a mobile crane of some sort. When that's just held next to the elevation that's being demolished, just to stop any fly going astray. And then finally is the top down in situ. The purpose here is to lift small plant up onto the roof and remove the structure panel by panel, floor by floor, and then until the whole structure is down to usually around the third or fourth floor, at which point a large excavator can mechanically remove the remaining structure from the ground level. This leads us to our case study now, which is using this particular strategy, which is on Coventry Point. So this project includes the top-down demolition of 2 linked large panel system structures slap bang in the middle of Coventry city centre. The client was Coventry City Council. The principal contractor was Coleman and Company, and the And I was, yeah, so they were the demolition contractor as well. And I was the lead temporary works designer and temporary works supervisor for the job. I, one of the temporary works supervisors. I worked very close with the site team and regularly visited to carry out site investigation works and various inspections, etc. The building was a local landmark and it was being cleared to make way for the council plans to regenerate the city centre. The ground level of the building was incorporated into the high street with restaurants and shops all at ground floor level. And this was also one of the key risks. There was also a link bridge as well that went from one of the towers to a multi-storey car park, which you can see on the right-hand side of that right image. The key constraints for this job was the proximity to the public, as the shops and the buildings remained open throughout the works around the structure, and not forgetting that this was an LPS structure. So here is illustrated the general sequence of the in situ top-down demolition. Plant is lifted on the roof, the structure is demolished floor by floor until it is no more. This is typical for most other top-down demolition methods, really, but the difference with the LPS structures comes in the additional methods or temporary works that must be considered during this process. So to facilitate the demolition works, there were several temporary works items that were required. And these were the global stability assessment, comprehensive SI review, and desktop study. And that included me contacting Bison, who were the manufacturer of the panels, to get some insider information on how they were constructed, because the different systems were slightly different. Demolition sequencing work, precast panel stability works, including the propping design to the panels, plant justification, link bridge demolition, scaffold and hoist checks. Some of these items are self-explanatory or typical for other top-down schemes, really, but I'm going to focus on the design items that were associated with it being an LPS structure. Risk number one. So what exactly are we working with here? Extensive site investigation is required to ensure we had a good understanding of the structure. We worked hard with Coleman's to establish a robust schedule of investigations. This investigation scope would hopefully identify how well the structure was put together. Was it a thread in the shed kind of company who threw it up in no time at all, thus leading to missing loops in ties, etc.? Or was it actually properly constructed? In this case, the structure was constructed relatively well. There were no instances where panels failed prematurely due to latent defects, which is great. So here is an example of one of the site investigation plans that we provided, detailing exactly what we were after. And we wanted to take a reasonable sample of the structure to get a representative feel for the structure. Here's the underside of one of the floor planks. You can see the pre-tension strands in the bottom face. The white stuff is a kind of a filler, like a polystyrene kind of filler. And then the ends of the planks you can see there have been filled with concrete. This is to provide a greater shear resistance at the supports, where there's usually the highest shear loading. And then also we've got here a connection where the panel connects down to the floor. And you can see there that the dowel goes through the loop. Hey, that's exactly what we wanted to find during the site investigation works, and that shows that you know, the panel and the floor are connected together properly and as it was designed. Wow, that is high. This is one of the elevations that you can see from me stood there at ground level where the shops are. The scaffold would eventually encapsulate the structure, but, and this leads us on to risk number two. How do we prevent some of the panels becoming unstable once they've had their head restraint removed? The wall panels rely on the self-weight of the floor panels. The wall panels rely on the self-weight of the floor panels to maintain their stability. Therefore, once the floor above is removed, we need to put another support system in place. So on this project, we utilized simple raking props, which were bolted to the walls and the floors. And we also designed a tension tie lower down to prevent the panel from essentially kicking out at the floor level. This tension tie was just a simple 1.5 ton ratchet strap tied to fixing through the wall and tensioned up just to stop it going outwards. This system ensured that the panel would remain stable during both the demolition of the floor slab as well as the demolition of the wall itself. So that deals with the bigger stuff, like the large panels, but what about the smaller debris, which can filter through the scaffold, and we don't want that falling down. So high above the high street, it is really important to prevent the small bits of concrete, scaffold clips, small tools from falling, as this can fall to the ground with quite tremendous force when you're that high up. And here you can see some simple methods of achieving this. So we used screens to deflect the material towards the building, inside the building, and this worked very well with the beams over the windows as shown here. Another method is to encapsulate the building with scaffold that's sheeted and also has demolition fans as shown here. This essentially captures falling items during construction and stopping it from hitting the ground. And this is also true when striking the scaffold as well as constructing. The scaffold was also detailed to have a 4mm ply board screwed down to the working level, which then would prevent the small debris filtering through the scaffold boards. Another protection measure that was employed was to construct a proprietary deck in the area that was closest to the tower. As this was a key thoroughfare through the city centre, we needed to make sure that we were protecting the public suitably. So this deck essentially encapsulated the whole walkway along that elevation. So the combination of all these methods, working from the source where the plant is down to the crash deck just above the public, mitigated the risk of the falling objects and ensured the safety of the public, and also mitigated the risk of the LPS structure. So that covers the protection methods that protect the public should any material leave the top of the tower, including the risk from the LPS structure. But isn't that more of a reactive method that doesn't really focus on the source of the hazard? The most effective method of reducing risk, as we know, is, well, it isn't reducing the risk at all. It's totally eliminating the hazard. But in this case, the hazard is the demolition. So we can't really eliminate that because that's the project task. But we can carry out the demolition at times when there's no public around. The solution here was risk zoning. We identified red, amber, and green zones according to the risk in that area. The red zones were carried out outside of normal hours, whereas the amber and green were carried out in the day, providing that the planned exclusion zones into the public zones were adopted. So the best way to reduce risk is to eliminate it, which follows the ERIC principle of risk reduction being eliminate, reduce, inform, and control the risk. So now that the risks have been mitigated, it was a case of carrying out the works as planned. And here is a photo of the structure as it's on its way down, getting shorter and shorter, floor by floor. And this photo was taken from the top floor of one of the car parks opposite. And then the job was complete, just like that. That was obviously not simple, but it was a good project. And this last picture illustrates the mushroom that was at third level, that acted as the third level podium on one of the towers, and it was removed essentially with a large excavator at ground level. So to summarize on this project, the key challenges were in reducing risk, the structure being LPS, and an extensive site investigation, intrusive site investigation scope, and the proximity to the public as well. This project was successfully completed last year. And to summarize on LPS structures, these are structures that must not be taken lightly, but can be demolished safely, providing suitable risk mitigation is considered during design stage and also during the demolition work. So here at Andon, we've got the knowledge, the experience, and the understanding of these risks. And we also have the knowledge, experience, and understanding of the practical application of the risk mitigation required to ensure a safe demolition project. So thank you for listening. If you would like to know a bit more about LPS structures, there's a lot of information that the BRE have in reports. There's also information provided by the Institution of Civil Engineers. And for temporary works in general, there's the Temporary Works Forum 5975, and also the Temporary Works Principle in Design and Construction book as well. So again, thank you for listening. I think we'll take a very short break.